Hi everyone, Mr. Neighbor here, and today we're going to talk about the SI system.
3, 2, 1.
Thank you. The SI system, or SI units, is the international system, and it's used by scientists for measurements and to make calculations around the world for science experiments and observations. It relies heavily on the metric system, and it's adopted by every single country except the United States, Myanmar, and Liberia. Those are the three countries that use the customary system, your feet, pounds, gallons. Everyone else uses the SI system, which relies heavily on the metric. So here's the SI system unit. Here are the customary units, and this is the type of thing that we're measuring. Just to give you some comparisons. So length is a meter, but we use feet. Mass is kilogram, but we use pound. Weight, different than mass, is a newton, but we use pound. Volume is a liter. We use gallons. Temperature is either Celsius or Kelvin, and we use Fahrenheit. So for example, length, which is a distance from point A to B, they use meters. A common conversion is 1 meter is about 3.28 feet. For mass, that's the amount of substance there is, amount of matter. This number doesn't change whether you're on Earth or in outer space, and it's measured in kilograms. So the conversion is 1 kilogram to 2.2 pounds. Weight, similar but different than mass, is the measure of force of gravity. This number will change because the force of gravity on Earth is different than the force of gravity in space, than on the moon or on any other planet. It is measured in newtons. Here's a common conversion, 1 newton to 0.225 pounds. Volume is the measurement of space taken up by an object. It can be calculated by how much fluid is displaced. So you put an object in water, and then we see how much water was moved. And that's measured in liters. A very good thing to remember is that 1 milliliter is equal to 1 cubic centimeter. So volume we usually calculate in math with some three-dimensional object, and it gives us out a quantity of something cubed. Once you have that something cubed, you can then convert it into the liter label. For SI units for temperature, it's how a measurement of the particles vibration in a substance. So water particles aren't vibrating super fast, but when that water turns into steam, those atoms are moving very fast. They're vibrating very fast because the temperature went up. It's a measure of the heat or the particle vibration. More particles vibrating, higher heat. Measured in Celsius or Kelvin, and here are some formulas to calculate those. Time, that doesn't change between the customary and SI system. It's just a measure of a measure in which events can be ordered from past through the present and into the future, and its label is typically seconds for the SI units. Some notes about math problems. You always want to store numbers in your calculator. When you have a SI calculator, or sorry, not an SI calculator, when you have a TI-83 calculator, TI-84, or any smart scientific calculator, you can store numbers by having the number on your screen. So have that number typed in, or maybe you have it as ANS because you just brought up the answer. Then you click the STO button. So at STO, and it has like a little arrow in most cases. That means store, and you're going to store it in, and then you choose the letter that you want. So a lot of times you have to click alpha to get the letters to pop up, and then you click the key that has the letter you want above it. I typically label things according to like what they are. So if I'm measuring the dog, I might put it store this in D. So D on my calculator is the X to the -1 button, and you see the little D above the button. So once you do that and then hit the enter button, it will be stored in the letter D. So every time you punch in the letter D, now it is going to be that number. Some people want to clear it for some reason. You just type a new number in. If you don't want that number, then go ahead and change it to be 0. It doesn't really matter. So that's how you store numbers into your calculator. A lot of times we want to write in scientific notation if it's large or small numbers. We haven't talked about scientific notation yet, but we will. So if numbers are really, really small, so they have 0.000000, we don't want to write all those zeros. We just care about the 4-1 at the end. So we're going to write it in scientific notation to make that easier on us. Next, we're going to use something called sig figs if you're in honors. If you're not in honors, you're probably just going to round to 2 decimal places. You'll learn about sig figs, but in general, you're just going to round to 2 decimal places after the decimal point. Never leave a decimal out in front, and always include a 0. So we don't want to see this by itself. We want to see a 0 in front of it because we don't want this decimal point to be lost. And always include units. Units are super important when it comes to physical science or physics because those units help you calculate things. For example, meters per second or even miles per hour. Those are both speed calculations. They tell you how to calculate speed. Take miles, divide it by how many hours it took you to travel. Take how many meters you traveled, divide it by your seconds. So units are huge when helping you calculate things. So always remember units. So for an example, when we're talking about this problem, you have rock with a volume of 15 milliliters and a mass of 45 grams. What is its density? So density is calculated by the mass divided by the volume. So I would take 45 grams, notice I'm going to write the G for grams, divided by 15 milliliters, and I'm putting that label in. So when I take 45 divided by 15, I get out 3, and those labels are going to stay. And that is the label of my answer. Here's another example where we're talking about something, we're talking about aluminum, and we want to calculate the volume. So remember, density is equal to mass divided by volume. So calculate the volume of a sample of aluminum that has a mass of that much and a density that is that much. So density is 2.70 grams per milliliter, or centimeters squared, or cubed, sorry about that. Then we have the mass, which is 3,057 grams. And if you're comfortable with math, you can realize that I would multiply the V over, and then I would divide the D over. So I really can switch these around. So I will have, I will have 3,057 grams divided by 2.70 grams per cubic centimeter. The grams will actually cancel each other out. And my final answer, which we'll talk more about in class, will be an answer that is just centimeters cubed, and that centimeter cubed will be in the numerator. It will come out to be this down here. Another cool thing is, remember, every cubic centimeter is 1 milliliter. So this label could also be milliliters if you wanted it to be. Even though it says centimeters cubed right here, it's another way to write as milliliters. So very neat. Next, I want to talk briefly about conversions in the metric system. So in the metric system, we have prefixes, and those prefixes relate to different powers of 10. So for example, the width of a soccer goal is 7 meters. 7 meters is our base unit. We want to know how many centimeters that is. So one of those is 10 to the second centimeters, which is 100. So every 1 meter is 100 centimeters. So that'd be 700 centimeters. Here we have French fries, and it contains 150 milligrams of salt. How many grams is this? And actually, I think we're going to save this for another video just because I'm running out of time. So I'll see you next time. Bye.